this video, we'll review the concept of function notation. Now, in previous lectures, you have learned about how to identify whether or not something is a function, whether it's a graph, a relation, or an equation. Now we're going to talk about when we know that something is a function, how can we write it? We have function notation, y equals f of x. When we see this f of x, what's in the parentheses is representing our input. In other words, it's what we're going to plug in for x. So given the following functions, we're going to find g of 0, f of -5, f of 2, and f of -1. We have g of x equals 4x plus 5, and f of x equals 3x squared minus x plus 2. To find g of 0, and careful with the way that you say this. This is not g parentheses 0. It's not g times 0. Because of the notation and the context at which this is being used, this is read g of 0. This tells me I'm going to substitute in 0 for x in the function g. So this is 4 times 0 plus 5. Now if I simplify this, 4 times 0 is 0 plus 5 is 5. Now with function notation, when we're evaluating a function, we're actually generating an ordered pair. An ordered pair is x, y. X is our input, y is our output. In this example, the input was 0 and my output was 5. So I just generated the point 0, -5 on the graph of g. G of -5. Now we're changing the input to be -5. 4 times -5 plus 5. 4 times -5 is -20. Plus 5 is -15. Again, we can talk about the ordered pair generated. Our input was -5 and our output was -15. F of 2, now we're changing functions. Our input is 2, and now we're plugging that into our function of f of x. 3 times 2 squared minus 2 plus 2. Well, when I simplify this, I see that those two are going to sum to 0, and I just got 3 times 2 squared. 2 squared is 4 times 3 is 12. Our input for this was 2, and the output was 12. This is a point on f of x. Again, these two were points on g of x, and now we're going to find some points on the graph of f of x. F of -1, when I'm substituting that value of -1 in for x, we want to make sure that we're using parentheses. 3 times -1 squared minus -1 plus 2. Simplify what you can. -1 squared is +1 times 3 is 3. When I subtract a -1, that's the same as adding 1. Plus 2, 3 plus 1 plus 2 is 6. And the ordered pair that we have generated now is -1, 6. So these are 2 points on the graph of f of x. Anytime you see notation like this, they're not asking you to multiply g times whatever that number is. That is a notation indicating that you're taking the value inside parentheses and plugging it in for your variable. Now let's use some graphs to answer questions about function notation. Use the graphs to find f of 2 and g of 3. Notice there are 2 graphs here, but they're labeled. This one is labeled f, this one down here is labeled g, so this we will use as the graph of f, this we will use as the graph of g. In these 2 examples, f of 2 and f of 3, ask yourself, what information are they giving you? They're giving you the input. They're giving you x, and they want you to find y. So how do we do that with the graph? For f of 2, again, we're using this top graph. We want to find x equals 2, which is right here. And then we just want to move our pen up so that we intersect the graph. And that's the ordered pair that they're referring to. When x is 2, what was the output on, or what was the output of the graph, or what was the y value? It was 1. So f of 2 equals 1. When we want to find g of 3, again, now we're using this bottom graph. I'm going to go over to x equals 3, and I didn't have to move up or down to hit the graph. My graph intersected right there. So g of 3, the y value right here is 0. Using these same graphs, now we're going to change the question a little bit. They want us to determine or approximate the x values such that f of x equals 2 and g of x equals 3. What is different about the way that they've presented the problem here? I asked the same question. What information are they giving you? In this case, they're not giving us the x value. They're giving us the y value, and they want us to find x. Now that's also stated here when they say approximate the x values, but again, understanding the notation is important in case that's not part of the directions. So f of x equals 2. Here's the graph of f of x. They're giving us the y value, so they're telling us that the y value is 2. Now where on this graph do I have a y value of 2? I have one here and another point here. What are the x values for this? One of them is -4, the other is +4. So we actually had two solutions there. For the next one, we want to find where does g of x equal 3. So again, we look at our y-axis for 3 because 3 is our y value, and we go across to find the points that intersect the graph. If I move to the left, I see that I'm not going to intersect my graph at all. But when I move to the right, I get a point about there. Since it doesn't land on a nice crosshair, we will use approximating techniques to figure out what the x value is. There is a difference between a good approximation and a bad approximation. If I'm approximating this, I can see that it's more than 3.5 and less than 4. So maybe I might say that x is approximately 3.75. And that squiggly equal sign, that's the symbol we use when we are approximating a value. The function f of x equals 0.55x plus 0.3 gives the approximate, that's not spelled right, approximate number of students enrolling for classes online X years after 2000. And it gives the number in millions. Approximate the online enrollment in 2020. So if I'm trying to find the enrollment for the year 2020, we need to figure out what our input is. It says that X is the number of years after 2000. So if it's 2020, what does X equal? X equals 20. Because it's 20 years after 2000. So now we're finding f of 20. And again, that just means to substitute in 20 for x. 0.55 times 20 plus 0.3. Go ahead and grab your calculator. In a problem like this, it is acceptable to leave your answer as a decimal because there are decimals in the original equation. So take a second, type that in. We should get 11.3. Now we have to add some units to this because it's unclear what that means. Is it 11.3 students? That seems unlikely. But look at the problem again. They tell us that this gives the number of students in millions. So it's 11.3 million students, which seems a lot more reasonable if we're thinking it's 2016 now. In 4 years, the number of students enrolling for classes online is probably going to be quite a high number. Certainly more than just 11.3 students. Okay, we're going to go back to just traditional function notation, but now instead of plugging in a number for our input, now we're going to look at substituting in an expression. So we want to find f of negative x and f of x plus 1. We're using that function we had before, f of x equals 3x squared minus x plus 2. Now, before I do that, I want to just show you one thing. If I see this notation, what does that notation tell me to do? Well, we should be programmed to see this and say, okay, that tells me to plug in a smiley face everywhere I see an x. That's not meaningful to us. There's no reason why we would ever want to plug in a smiley face for x, but that's what this notation tells me to do. If I see this, f of star, that means plug in a star everywhere you see an x. It doesn't matter what's in the parentheses. The way we evaluate, it's always going to be the same. Whatever's in our parentheses, that's what we are substituting in for our variable. So in this first one, f of negative x, I'm going to substitute negative x everywhere I have an x. So this looks like 3 times, instead of x squared, it's negative x squared, minus, instead of x, a negative x, plus 2. When I simplify this, negative x times negative x is the same as positive x squared. So this is 3x squared. When I subtract a negative, that's the same as adding x plus 2. And we're done. There's nothing else we can do. It's not going to simplify to just a number because our input wasn't a number. On the next slide, we're going to look at f of x plus 1 just so we have a little bit more space. This tells me to substitute x plus 1 everywhere I see an x. So let's look at what that looks like. Here's my x plus 1. I'm going to plug it in there for that x. I'm also going to plug it in there for that x. So this looks like 3 times x plus 1 squared minus x plus 1 plus 2. Notice the use of the parentheses because I'm not just talking about one term. I have a binomial here. Just like when we had the negative, we wanted to make sure we used parentheses. This x plus 1 squared, hopefully we remember that whenever I'm squaring a binomial, I need to FOIL it out. So we're going to write it out twice. 3 times x plus 1 times x plus 1. For my second term, I'm going to distribute the negative sign. Negative x minus 1. And then that plus 2 is still hanging out at the end. Next, we are going to FOIL those two binomials. So I've got the 3 hanging out in the front still. First, x times x is x squared. Outer, x times 1 is x. Inner, 1 times x is x. Last, 1 times 1 is 1. And now I'm just rewriting what I had before. And next, we will take the 3, we will distribute it. Actually, I'm going to combine like terms first in the parentheses. So we have 3 times x squared plus 2x plus 1 minus x. I'm also going to combine those like terms. Negative 1 plus 2 is positive 1. And now I will distribute that 3. 3x squared plus 6x plus 3 minus x plus 1. I have no more parentheses. The last thing I have to do is combine like terms. 3x squared has no other like terms, but we have a 6x and a minus x, which are like terms, which is positive 5x. And we have a positive 3 and a positive 1, which is positive 4. So this expression represents f of x plus 1. A lot of algebra, a lot of really basic algebraic skills in this problem, which make it seem a little bit more challenging, but it's really not. You just have to take your time and make sure that you're keeping track of all your terms and your order of operations. So again, with function notation, when we see f with the parentheses, that's just telling us to take whatever's inside the parentheses and plug it in for our variable. We saw how we can use function notation and derive answers or information from the graph, and an application using functions. I encourage you guys to make sure you practice this skill because it comes up a lot, and if you're not very comfortable with it, you might misread it. Again, context of the question is going to indicate whether you're multiplying or if it's function notation. Thanks, guys. Have a great day.